Hey guys! Okay, we're going to start with lesson 2 in module 3, and there's a super lot to cover, so I'm going to jump right in. There are a lot of notes, so take what you can. I'm going to do my best to explain them as quickly as possible. And again, just pause the video when you need more time, but it's all really important. So the objective here in lesson 2 is to make equivalent fractions with sums, that means the answer to an addition problem, of fractions with like denominators. And so like denominators means it's the same number on the bottom so that you can add, because we're talking about the same unit, like adding apples with apples or oranges with oranges, not apples and oranges trying to be added together. That wouldn't work. For fractions, it wouldn't work. Anyway, fractions must have the same number on the bottom to add or subtract. Okay, super vital. The number on the bottom is called the denominator. And go back to lesson 1 notes to get that, or the preview. Anyway, making equivalents, we have been doing, that's lesson 1, trying to have the same number on the bottom so that we can put them together. So you would be thinking about how to make this many parts from this number. So I always think of it as, let's find the missing factor. Like 2 times what is 4? 1 times that same number will give you your new numerator. And so 2 times 2 is 4, therefore, and I'm going to say this about 1,000 times, what's on the bottom goes on the top. So it's going to be the same factor so that you can keep these in the same ratio. That's how you get equivalent fractions, is by keeping the first fraction and your equivalent fraction at the same ratio to each other. Okay? So that's all really important, and we kind of will do a little bit more with that. Now I'll move on to more in a minute. But this notebook this year, I was really following in the preview to the book. So we also today are going to be working with number lines. And I almost never use a ruler, but if you have trouble making straight lines, please use a ruler. So we're going to plop down some number lines. The first example problem is to just draw a line, put your arrows at the ends, and label it with 0 and then 1, 2, 3 parts. Thirds is what we're dividing this into. So every number forever on this number line would be a 3. When we add 1/3 to 1/3, you end up at 2/3. And it's like, yay, it's so easy. 1 plus 1 is 2. It's 1. That's exactly what it is. Nothing to it. Move on to the next one, number line. And then 1/4 plus 1/4 plus 1/4. There you find yourself at 3/4, and it's correct. 1 plus 1 plus 1 is 3. So that's all there is to it. On the next number line, if I divide it into eighths, always starting at 0, so there are 9 hash marks, 0, 1/8, 2/8, 3/8, etc. Then what if I had different numbers that weren't 1? What if I had 3/8 plus 3/8, and then one that didn't match? That's fine. Showing it on a number line can be 3/8 plus 3/8 plus 1/8. And so you'll be doing that today in the lesson. 3 plus 3 plus 1 makes 7. So that's how you show that. There's another problem that they're going to ask us to split things up into equal parts today. So let's say you take halves here. So draw a number line, and instead of having like less than 1, we're going to have more than 1. So if I divide each 1 into 2 parts, then I have 0, 1/2, 1, or 2/2, because if I'm dividing it into halves, each 2 is on the bottom forever. 1.5, 2, 2.5, 3. So how do you count that in fractional units on the bottom? 0 halves, 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. So all these are halves, but you can put them together to get more than 1, or get what you'll call a mixed number, like 1.5, a whole number and a fraction. So the book's going to give you like 6 halves. And they'll say, okay, let's break this up into even groups. And so what you would need to do is look for a way to make the same sized grouping so that you can multiply. If I have 3 of the same thing, then I can set it up in a multiplication expression. And so this is going to be helpful when we get lots of bigger numbers. Okay? And the last one for this particular lesson, another number line, but dividing each one into 5 parts. 1/5, 2/5, 3/5, 4/5, 5/5. Say that 10 times fast. And so if you have all your fifths going up to 2, which is 10/5, let's take a number like 8/5. Can you divide it into equal parts? This is going to be non-equal parts, but 4/5 plus 4/5 would be 8/5. And then you can have 2 times 4/5. So there are all these different things that we're going to be talking about. That's that notebook. Now back to this one. Not necessarily worried about making equivalent fractions just yet because they're going to give us some easy stuff today. But if you have to make equivalent fractions, again, find the missing factor. 2 times what is 6? Well, 2 times 3 is 6. If whatever you use on the bottom, you use on the top so that you can keep the ratio the same between the first fraction and the equivalent fraction. When we did our fraction boxes in the previous video, if you have half of this shaded to begin with, okay, and then you divide it into 6 pieces, 3 of them are shaded. So it's still half shaded. That's why those are equivalent. And I think everything else has been covered previously. So let's jump into the book. Okay. And I probably will end up putting down the answer key in a few minutes. I want you to get a chance to make them on your own, and then it takes a long time with all the little tick marks and everything, so we'll do our best. Show each expression on number line and then solve it. Now, this is super easy. Like, you just look at it, and I want you to know 2 plus 1 is 3. The answer is 3/5. Okay, no surprise there. 1 plus 1 plus 1. The answer is 3/3. No surprises. It's easy. That's all it is. Adding fractions, if the denominator is the same, just fire away on the top, okay? But with this fun program, they don't make it that easy. They want you to really understand the addition behind it. So make a number line. And how many pieces, or what do we divide this into? We're going to divide one whole into 5 parts, always starting at 0, and use the bottom for your fractions, and then go 1/5, and try to make them equally distanced as best you can. 3/5, 4/5, 5/5. Now, every time you get a number over itself, that's a whole number. So this is 0, and this is 1. It means all the parts out of the total number of parts. If I have 5 parts and I have 5 parts, then it's a 1. Okay? And there's no need for us to number beyond that because our total is going to be less. So on the number line, you're going to start at 0 and go from 0 to 2, and then add 1 more fifth to show that you end up at 3/5, and then you can write your answer, 3/5. It's so easy. Isn't that great? Don't you just want to, like, jump up and down? And I did jump up and down before the video so the lights wouldn't go out, but we'll see how long that lasts. Anyhow, we know the answer is 3/3. Now, we also know that if you have all the parts out of how many pieces you broke it into, that's going to be a whole 1. So make your number line. Just draw a straight line. Start with 0/3. Again, the bottom number is the number that you are counting by in pieces. 1/3, 2/3, or 2 out of 3, 3/3, and that's also 1, 0, and 1. Showing it on a number line, 1 plus 1 plus 1. So that's your final answer, and it's also right here and right here. So it's all equal to this is all equal. 3/3 is equal to 1. Next one. We know that 3 plus 3 plus 3 is 9. Go ahead and put your answer. It's easy peasy. But now we have to make a number line. Now this number line needs to be in 10 parts, and I need to get all the way up to 10. So 0 tenths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just, try to make them equally spread apart because that's what fractions are. They're in equal pieces. 10 tenths is equal to 1. It's 1 being broken up into 10 pieces. So start numbering, and I know a lot of kids, when they get really tiny, we will only number every, say, 5th tick mark. So 1 tenth, 2 tenths. If you're struggling to fit them, just count the even ones. 4 tenths, 6 tenths, 8 tenths. And then you can fill in when you need the answer, like here, 3 tenths. So you can fill that one in so you see what you land on. And then 1, 2, 3, bam. But we need another one. 1, 2, 3, let's answer that one, 9 tenths, and bam. That's where you end up. So see, isn't that fun? This is totally fun. You guys can do it. Oh, what is this? Okay, this is all right. What they're telling you here is, let's rewrite this. It's really 2 of these. Okay, if I was going to put parentheses in, because I have to solve multiplication first, according to PEMDAS, see the other video on PEMDAS. According to PEMDAS, multiplication and division have a higher authority or power or strength than addition and subtraction. So even though they don't have parentheses here, I always put them in just to force me to think about, what am I doing with this? And now I'm going to turn this into an addition problem. I'm going to have 3/4 plus 3/4. That's what this means. Okay? This whole thing is an addition expression to show 2 times this number. Okay? Then I'm also going to add 1/4 when I finish that. So when I do my addition problem first, I will have 6/4, and then I will have another 4th. And I know I'll end up with 7/4. And I'm going to put a number line. And I have to divide it into 4ths, but notice that I have 7 on top. Oh, and I remember I had a funny thing I was going to show you about improper fractions. Oh, yeah. This is on one. I think I skipped this part. But here in the notes, focus. Here in the notes, anyway, it'll come together in a moment. It says improper fractions. We had talked about it previously in another video. And I said, oh, I'll draw a picture for you. It has a larger number on top. And there we go. It just didn't want to focus. It has a larger number on top. So it looks really, what I think, funny. And so I always like to think of like this cartoon character, like, whoa, the really big noggin. And that means the number on top is bigger. That means it's greater than 1. So if I was to change an improper fraction to a mixed number, I would have a whole number and leftovers. Okay? So I have 5/5 plus 2/5. This is representing 5/5. This is representing 2/2 plus 1/2. Okay, so this is 10 tenths plus 4 tenths. So that's what mixed numbers and improper fractions look like. And so that in itself is something that we'll be touching upon many times during fractions. So here we have our improper fractions. So far the previous ones were all proper. And this one is improper. So I still have to make 4ths. I have 0/4. 1, 2, 3, 4, 4/4. 5, 6, 7, 7/4. So what does that look like when I am counting out all my 4ths? 5/4, 6/4. So just keep your counting like that, and we have 0. And where's the 1? 4/4, right there. Where's 2? 8/4. Guess what? Remember when this bar I said was a division sign? 8 divided by 4 is 2? It's true. Still there. So 3/4 plus 3/4 plus 1/4 would look like that, plus 1, 2, 3 plus 1. And that's where you end up with your 7/4. You have got this. Okay? Now, this part, really important to recognize that you can take apart a number and put it in equal 2 or 3 equal fractional parts. So what are we at, 15 minutes? Okay, let's try to get this done. 6 can be broken up. It's an even number. So I'm going to take this and divide it by 2, and I'll do 3/7 plus 3/7. We only have to show part A on a number line, and then the others will just solve. So I need sevenths. I have 0/7, 1, 2, 3, 4, 5, 6, 7 sevenths. We'll get that up to 1, 0 and 1. Now I have 1, 2, 3, 4, 5, 6. 3/7, 1, 2, 3, plus 3/7, okay, makes the 6/7 we started with. Now we also have to rewrite each one as a multiplication equation. So this is my rewriting it as the sum of 2 equal fractional parts, but I also need a separate answer that looks different. Now, how many times am I repeating this number? Kind of like up here. 2 times 3/7. And then we leave it like this because this is the expression. We're just setting it up. We're solving it backwards. We're seeing what parts it's made of. So this is the answer to that. Okay, I know you guys think, but that's the answer. Well, this is the answer today. The answer is to break it apart and see what it's made of. Now, what if for this one it's an odd number? Can I have equal parts? Well, not if it's in 2 pieces, but what if it's in 3 pieces? So 9 in 3 pieces would be 3/2 plus 3/2 plus 3/2. So we're just trying to break this up so that I could do 3 times 3/2. And when I get this far, I'm done. I have my rewritten expression as the sum of 3 equal fractional parts and then as a multiplication equation. Next, I have an even number, which means I can have 6/10 plus 6/10, or 2 times 6/10. But I have other students who have said, but you can do 4/10 and 4/10 and 4/10. And that is also true. Oh, hey, yeah, I'm almost done. I'm just doing a video. Yeah, that's okay. I'll be out. Pull out a desk. I'll be out in a few minutes. And then we have 12/10, okay, which is what we got. But then we're going to have 3 times 4/10. Can you tell it's lunchtime? All right, so 3 times 4/10 is our answer. Now, what about fifths? Can 27 be divided into 3 equal parts? Yes, it can. 27 divided by 3 is 9. So 9/5, 9/5, 9/5, and that would make our 27/5. Now, how many times did we do that? 3 times 9/5. So that's all you need for that part. Then we move on to the back. Now the back has the same type of thing. Okay, express the following as the sum of a whole number and a fraction, and show parts C and D on number lines. So if I have a whole number, remember a whole number would be like 1 or 2 or 3, just a whole number. But a whole number can be any fraction with the number over itself. Okay, so like 5/5 is equal to 1. Okay, but so is 10/10. Okay, now a whole number and a fraction, that means it's a mixed number. And so the mixed number would be like 2 1/2. Okay, All right, so if I'm going to express each of the following as the sum of a whole number and a fraction, then I can take apart this number, and I want to have the biggest number of parts. So how many parts out of 7 could I get? I could get 7/7, okay, which is really equal to 1. And how many are left over? 2. So 1 plus 2/7 is 1 2/7. So we're kind of breaking it apart. And always know that because this is a division sign, it's 9 divided by 7. So this is where you're going to get your putting it together. 9 divided by 7 is 1. And I have 2 left over. And funny how I have 2 left over out of 7. That's what we're really going for here. This is the whole number. This is the remainder. And that makes a fraction. Okay? So what could I do here? How many times can I fit 2 into 9? How many times can I do that? I can fit it 4 whole times with 1 left over, which makes 4 1/2. And again, just divide it. Okay, there you go. You see that I'm using up those, and then I get the 1. That's what's happening. 32 divided by 7. Again, how many whole 7s can I get into 32? So I can get 4 7s, and then how many are left over? Well, what's the difference between 28 and 32? 4. 32 divided by 7. So that's what we're doing here, but I also need to show this on a number line. 4, 28, 4, there's your 4 7ths. Now what is the, ooh, this is tiny. It's so tiny. I'm going to actually flop down the bigger one because I have a better version over in my other book. So when you make 7 7ths, and then 14 7ths, and then 21 7ths, and then 28 7ths, that's your whole leap of 4. And then you just have your few left, your 4 7ths, and that's your little tiny fraction. On the next one, it is 24 divided by 9. And again, how many 9s can I fit in there without going past it? I can fit 2 whole 9s with 6 left over. And then your number line looks like this. And look, I made it too long, but oh well, who cares? And I may as well wrap it up with the answer right here. Maricela cut 4 equivalent lengths of ribbon. Each was 5/8, 1, 2, 3, 4, of a yard long. How many yards of ribbon did she cut? Express your answer as the sum of a whole number and the remaining fractional units, just like we did. So we have our 5/8 added 4 times, which gives you 28ths, which means I can have 8 into 20 2 full times with 4 left over. When you end up with 2 4/8, it's actually an equivalent to 2 1/2, which we'll be working on equivalents pretty soon. And then you would label your answer and, of course, draw your number line. 0/8, 1, 2, 3, 4, 5/8. Again, I'm not even numbering except for where I have the whole numbers and where it's relevant, where I'm counting to. So that's lesson 2 in a nutshell. Yay, I'm so happy. I love working with Module 3. I hope it's been helpful for you. If it's helpful, click subscribe. If it's not helpful, I'm so sorry. I'll try to do better next time. Have a great day.